11.3 Areas of polygons. Essential question: how can you find the area of a regular polygon? We'll start first by finding the area of a rhombus or a kite. A rhombus is a parallelogram, so you can use the formula A equals BH, but there's another formula that you might want to consider, and that's this formula: 1/2 diagonal 1 times diagonal 2. Let's see why it works. The first is I'm going to find the area of the top triangle, which requires 1/2 the base, and this base is D1, times the height, and this height will be half of this diagonal. Now, the area for the bottom triangle will be the same formula, so I'm just going to rewrite it. And so the whole rhombus will be both of these areas added up together. And you can see I'm going to factor 1/2 D1 out, and then I'm going to have these left over, and I'm going to add these two half diagonals together, and I get diagonal 2. The same strategy works for a kite. Look at how I find the area of a rhombus or a kite. So if you remember this formula, it helps you get to the area a lot faster. Your turn. Now let's talk about regular polygons. Regular polygons are equilateral and equal angular. And because they fit very well inside a circle, or a circle is circumscribed about it. So we use this vocabulary for a circle with regular polygons. So we're going to have a center, like we have a center of a circle, and it's going to be the center of the circumscribed circle. We are going to have a radius of the regular polygon. This is the radius of the regular polygon, which is also the radius of the circle. We are going to have what we call an apothem, and an apothem is this right here. It is the height of this triangle, this isosceles triangle, which is going to be very important in a few minutes. And we also have a central angle, which is made up of two radii, two consecutive radii, and that angle that's formed between them is a central angle. Let's go ahead and practice. We can see we have a regular pentagon. So first thing I'm going to do is to find the central angle. I'm going to take 360 and divide it by, there's going to be 1, 2, 3, 4, 5. There's a central angle for every one of the sides, and that answer will be 72 degrees. So this is the central angle, which is AFB, and that's 72 degrees. All right, now they would like me to find angle AFG. That's this angle right here. Now, remember, this whole angle is 72, and since this is an isosceles triangle, this angle will be 36 degrees. So I'll write 36 degrees, which is half of this number. Now they'd like me to find GAF, which is this angle, and we have an right triangle, and this will have to be the complement, which will be 54 degrees, and so this will be 54 degrees. So that's how we figure out these different angles inside a regular polygon. All right, your turn. Go ahead and attempt this. Stop the screencast and see what you can do. And here are the answers. All right, let's take a look at a square, and I'm going to call the side of the square S, and we are going to figure out the area of the square. Now, I know that you already have a formula, and it's base times height for a square, and since the base and the height are both the same, this is going to be side squared. I know we already have that formula, but I want to show you a different formula for a square that'll help you see the formula for a pentagon, hexagon, octagon, and so on. So here's the area of a square, and I'm going to, I know that I'm going to have 4 of these triangles right here. I didn't draw them all, I just drew one of them. So I'm going to have 4 triangles, and each triangle has that formula 1/2 base times height. So here's the 1/2, the base is S, and because this is a square, I know I have 360 divided by 4. Every central angle, this angle right here, is 90 degrees, and then if I take half of that, I get the 45, and so that's why I'm here. Now this is an isosceles triangle, so I know this part will be 1/2 the side, and because this is a 45, 45, 90 triangle, I know this is also 1/2 S. So this part right here is the height, 1/2 S. Now I'm going to rearrange things. I'm going to bring the 1/2 to the front here, and I'm going to leave this part alone, this 1/2 S, and I'm going to take the 4 and this S right here, and I'm going to put them together over here. Now the reason I'm doing this is because I want you to see what I have now. I have a half, and this part right here, the 1/2 S, is called the apothem. It's the height of this isosceles triangle. And 4S, if you have S, 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 and S, that's the same thing as a perimeter. And I want you to see that you can find the area of a square with this formula. That will lead us into this next figure. And we don't have a formula for a hexagon, but what we're going to use is the same strategy we used for the square. I'm going to take the central angle, which is 360 divided by 6, because there's 1, 2, 3, 4, 5, 6 sides, so that's 60 degrees. I'm going to take half of that angle, and that'll be the angle the inside. Now this is a 30, 60, 90 triangle. And if this length here is S, half of it will be 1/2 S, and that's the short leg. Now the long leg will be √3 longer, so this is going to be 1/2 S √3. I'm going to have 6 of these triangles, so here's the 6. I do know that I want to do 1/2 base times height for this triangle right here, and the base is S, so you can see right here is my base, and my height is the apothem, which I just figured out here. Now I'm going to rearrange things. I'm going to put the 1/2 here. I'm going to put this portion in the front here, and then I'm going to take this number 6 and S and put them together right here. Now when I do that, I'm going to have a 1/2. This is representing the apothem, and 6S is 1, 2, 3, 4, 5, 6. That represents a perimeter. So this is what I got with a square, and I'm getting it with a hexagon. And so now this, hopefully this slide makes a little bit more sense. So to find the area of any regular n-gon, all you have to do is multiply by 1/2 AP, where A stands for the length of the apothem, or the height of the isosceles triangle. All right, let's go ahead and try a problem. This is a nonagon. My nonagon, so the first thing I want to do is find the central angle, and that'll be 360 divided by 9, which is 40. Now that's this angle from here to here. I would need to find an angle inside the right triangle, which is going to be 20 degrees. So this angle right in here is 20 degrees. Now that's going to help me find my apothem, which I will call A, and then this length right here is I'm going to call X. Now X will be half of the whole side. We're going to go to the next slide so you can see my computation. All right, so there's my 20, and what I've done is I've drawn this right triangle nice and big so you can see it, and here's my apothem, and here's my X, and here's my 4. So I'm going to have to use trig to help me find my X. And you can see here's what my X is. I don't go to the calculator yet. Now the side is 2 times this number, so that's why you see the 8. The 4 turned into an 8. Now the perimeter will be 9 of these sides. So I'm going to take 9 and I'm going to multiply that by the side here. Now that's going to represent my perimeter in my formula. Now to figure out my apothem, I'm going to have to use another trig expression. Cosine 20 degrees is equal to A over 4. I'm going to solve for A, and that's going to be my apothem over here. So I put everything into my formula. I kind of multiplied everything out that wasn't in trig form, and then I went ahead and put it in my calculator. All right, let's take a look at this problem, finding the area of this octagon. Now, this octagon, remember the formula is 1/2 AP. Now, perimeter I can find because this is 15, and all I got to do is multiply it by 8. So 8 times 15 is going to give me my perimeter. That'll be okay. Now I just need my apothem. And since I know two sides of this right triangle, I am just going to use the Pythagorean theorem to figure out what A is. And then I go ahead and put A in here, and then I'm able to figure out my area. Okay, your turn. Go ahead and stop the screencast and see what you can do. And here's the answer. 1/2 AP. I have my apothem. You can see my apothem is right here. So I have my apothem. So I need to figure out what x is. Once I figure out what x is, I can double that, and that'll be my side. And since there's 5 of those, I'll multiply it by 5, and then there's my answer. Now, this was a decagon, has 10 sides, 36. Take half, that's 18, and I drew a nice big version of my right triangle. And the only thing I really needed was my apothem. So I went ahead and used the trig necessary to figure out my apothem, and I put the apothem right in here. My perimeter was easy to find because it was just 7 times 10, and then I had my answer.